All right, hey, Sean Morris at Schima again. As always, please like our videos and follow us. We really appreciate trying to build our presence, get this whole thing off the ground. So one of the things I want to talk about real quick in this video is the testing that we do on the products that we put up on the website to make sure that we're not giving you something that's going to fail or not get the job done. I work with a bunch of really talented engineers. So if you're wondering where this comes from, because I'm not an engineer, you're wondering where all the testing comes from and the skills involved, I have quite the crew of engineers, and I'm slowly going to one by one introduce them all to you, unless they hide or quit. So I'm going to bring one in here. This is Kyle. Kyle is one of the best engineers that you could have around. I think he actually heads our R&D department. And yeah, say hi, Kyle.
Hi, Kyle.
All right, now get out of here. So today what I'm going to show you is some of the testing that we did on some fuses, 100 amp hour A&L inline fuses. The same stuff you'd see in the car audio industry. We were shopping around, testing out some different fuses to put on the website. This is some of the aftermath. So this is a 100 amp hour fuse that did what it was supposed to do and gave up the ghost at 100 amp hours, which means it's going to protect your equipment if there's a surge or if your load's drawing too much current. To do this test, we had a couple of specific things we needed to do. We needed to draw over 100 amp hours, we needed to be able to connect the fuse, and we needed a power source. So we have a load in this box. It's 5 1 ohm resistors, large power resistors. Each one of those is going to draw about 25 amps from my battery when I turn the battery on. So that gives us a load of about 125 amps, give or take a few, because the battery voltage does come down as it starts to draw. And we've got some heavy duty 1/0 welding cable with the fuse mounted in there. And some older batteries that we had, some prototype batteries we'd built a long time ago. They're the same thing as what's in our Seahorse case, just these aren't fused, so I can draw much higher current from these batteries. So I connect the battery, turn the battery on, the resistors each draw the current that they need, and this fuse winds up being in a circuit that's pulling about 125 amps. It should go and do its job, pop and protect all of the equipment from failure or damage. And that's the kind of testing we did. We reiterated this with all of our fuses numerous times to make sure that the fuses we put on Schima's website are good quality and they're going to do what they're supposed to do, so you're not wasting your time or your money. And just to further drive this point home, we don't just do the math and guesstimate. We use things like amp clamps and multimeters all the time just to validate that what we're saying is actually happening. But yeah, testing at Schima. Thanks for watching, and like and follow us.